I want to thank the PHTA for hosting the World Aquatic Health Conference, and we're looking forward to providing you some great information. Our program is going to cover indoor air and water quality, and we can get it right with a little help. My name's Don Baker. I've been building pools for 47 years, and I'm a on-the-job guy as well as a guy in the office. Randy Reisen is our sales associate, and he has got experience in industrial engineering and very knowledgeable. Randy Baxter, who I would call the father of evacuator and source capture, was the man who challenged us to figure it out back in 2010, and Randy and I presented in Seattle in 2011. And at this point, I'm going to turn it over to Randy Reisen to present the pool portion of our demonstration and the water. Thank you.
Hi, I'm Randy Reisen, and I too am thankful for the invitation from PHTA to present our story and our recipe for success to the World Aquatic Health Conference. So good water quality is possible if you have a strategy and a recipe for success. And that's what we're going to talk about today. Don and I are going to break this topic into two portions. I'm going to handle the water side of the equation, and then we're going to talk about bridging the gap to the air side, and Don will conclude the presentation. Indoor swimming environments pose a unique challenge. You have to have a sanitizing agent such as chlorine or bromine. Those are the two most popular. And when you introduce chlorine into the pool, it combines with dirt, hair, skin cells, all the organics that we bring into the pool as swimmers and patrons to combine into disinfectant byproducts. So basically, those are the trichloramines that we're smelling when we go into a pool. It's not the chlorine that you're smelling, but the disinfectant byproducts. And those are heavier than water. We know that they are heavier than air, excuse me. They hang on close to the water, and that's where swimmers, other bathers, coaches, and patrons of the indoor pool experience the stinging eyes, the burning nose, and those other things that we don't like about indoor pools. So we know that swimmers introduce organics into the pool, and that oxidizing agents such as chlorine and bromine create the off-gassing disinfectant byproducts. We know from experience that when they off-gas, they don't go back into the water. They stay in the air. And you can also experience this from the pool surface, deck. If you have patrons entering and exiting the pool area, they can bring organics into the natatorium on their shoes, and then when the water is washed over the deck clean, you've got more disinfectant byproducts. Traditionally, HVAC systems don't reach the pool surface. If they do, they're disturbing the air and mixing it back into the HVAC system. So poor indoor air quality is created by a cycle of supply mixing with the trichloramines that we have on the pool surface. Some of it is dumped in the process, and new air is brought in, but you have a dilution of the problem. And when you've got a pool that is heavily used over the course of the day or several days, like a swim meet, you're going to have a buildup of these trichloramines. So there are three key components that we feel are important to discuss. Filtration. Obviously, we have to have appropriately sized filter for the turnover and the volume of the water in the pool. And then we need a chemical feed system to deliver the chemicals such as acid and chlorine to the pool. And then there's typically a secondary disinfectant system such as enzymes, UV, ozone, and there's a couple of others on the market now that are also having a positive effect on that topic of secondary sanitation. So we pretty much follow the guidelines of the PHTA and our recommendations. You'll see one difference over on the right side of the screen in green, and that is our recommended chlorine level. Over-chlorinating a pool can also cause problems with the air quality. We had one such instance a couple of years back where an operator was used to operating an outdoor pool at 4, and when he got his new pool and started operating it at a 4 indoors, he started contributing to the indoor air issue. So stay within that 1.0 to 1.5 parts per million chlorine and follow the rest of the PHTA guidelines, and we feel like you'll have good water chemistry. Pool maintenance is the other part of the equation. You need to vacuum your pool regularly, backwash your filters, clean the deck. We talked about it a little bit earlier. If you can limit patrons entering and exiting the pool off from the deck, that is helpful. We even have some coaches who don't allow people to wear street shoes in their pool. So use a non-oxidizing cleaning solutions, no ammonia or urea-based products, because you're going to combine that with chlorine and you're going to make the issue worse. So we've got some documents that we've provided that are helpful in this area, and we are also a resource for recommendations on cleaning products that you can use and ones you shouldn't use. Also, clean your deck drains. If you've got stagnant water in your deck drains and dirt, they're a source of trichloramines anytime deck water gets in there. Rinse and clean with fresh water regularly. Wipe down and polish all your stainless. And then patron hygiene is probably as big a contributor as any of these. So we want to educate staff and patrons on how hygiene impacts their water and air quality. We talked about showers. We talked about swim breaks, and that we've got some signs that we created with the help of the PHTA about you not using the pool as a bathroom. So if you have an adult swim every hour in the pool that you're operating, then you give people an opportunity to take a break and use the restroom. So if we operate safe and clean pools, and we have a good program for hygiene in our pools, then the job of the HVAC is the second part of this conversation. And this is source capture is a subject we want to talk about next, and that is the bridge between air and water. That links the pool with the HVAC and the mechanical system. And so I'd like to turn it over to Don to talk about the second part of this, which is the air side of the presentation.
Randy, thank you for a good insight on the water, which is a major contributor and opportunity to help make your air better. We've got some suggested information for you, and we call it a recipe for success for air quality. Just a little history. In the early 80s, 100% fresh air in, a little bit of heat or not, and when it got cold, it was a little tough in there. Back in those times, they moved enough air that there was not a chloramine issue. And in the 80s, they turned around and tightened the buildings up, energy codes, and added dehumidification. and really didn't study it as hard, and we started chloramine issues. Quick story, a university, we put a pool in the 70s with 100% fresh air. It had stainless components on it. They looked great. On the same university, that was replaced in the 90s, and the pool had chloramine issues that showed up as corrosion within 1 year that we had that operational. All right. The key is developing a chloramine mitigation strategy. And this is a conversation I've had for a lot of times. Have you ever spent more than an hour at a large indoor swimming pool on the fourth day and truly enjoyed yourself? What about an indoor pool and water park loaded with kids, water features, and everything, everywhere you look? The answer I received is typically a resounding no. There's no magic bullet out there. Suppliers say they've got it, but it's not. It is a collaborative effort by all folks on the design team and suppliers of equipment. It takes a design team that takes into account all the parts of the natatorium: air, water distribution, chemical control, secondary disinfection, and creates a recipe to provide great indoor air. This has been an ongoing conversation, and CMAC has been involved with Purdue University, Chip Blatchley, and he's a great resource for studying air quality and water quality. And there's an ongoing study. We've done phase 1 and 2, and they've come up with some good measurements and tools to help predict your air quality. With that said, we have a third part of this study to go beyond the first few pools we've got so that we can expand it to different types of pools and get that information to help develop plans for the future. Now, I'm on committee with the CMAC, and we've got a bunch of good folks on there, air and water, and the CMAC folks. And if you're interested in supporting and participating, reach out to Christy Reister. She's a great gal, and they want to help us out. The effects of poor air quality indoor pool. We all have been out there. Eyes, nose, throat. Your eyes burn. The soft tissue in your nose burns. There's a possible link to asthma, and you hear chloramine-induced asthma. Lots of folks quit swimming because they can't breathe in that environment. The chloramines are heavier, and they just happen to be sitting right on top of the water. And they're heavier than oxygen, so they displace oxygen. CO2 is also an off gas from our activity, and it also displaces oxygen. So those two airborne contaminants will impact your ability to process oxygen, therefore in competition, in general, how you feel. There are other health concerns, and it will rapidly wear down your building. And if it can break down carbon steel, aluminum, galvanized, what's it doing to you and me? Indoor pool air quality is basically caused by ineffective removal of disinfectant byproducts. The basic HVAC designs didn't take it into consideration as well for the last 30 years, but every day we are progressing and coming forward. The disinfectant byproducts are disinfectants doing their job. And we have organic chloramines, which is dirt and carrying on, and we also have some inorganic. And in the inorganic, it starts with a monochloramine, tri, and then it comes out in the wash, it shows up in the air. This is a detail that we got from Arenda Products, which basically shows us how bad ammonia affects us. Ammonia will come in there and pick up a chlorine at a mono level, 2 chlorines at a di, and 3 at a tri, at which point they become highly volatile, corrosive, and come out in the air very easily. In the past, there were some thoughts on how to deal. Don't use chlorine and bromine. That's a little scary because we have a lot of contaminants in the pool that you have to deal with. So we have to have that disinfectant. Keeping nitrogen-containing compounds out of the pool is important, as Randy mentioned with cleaning solutions that are on the deck that we may not be concerned with. Excessive superchlorination is one of the old school, but again, then you have to knock it down, and that's not so good. We want people to shower before they enter the pool, which is key. And if they don't pee in the pool, is helpful. If they don't sweat or no people in the pool, we get a nice clean pool. But that's not really in the game. All right, old solution number 2. How do we get rid of them after they form? In the past, back in 2011, the solution that was proposed was solution by excessive dilution. They were running 2 to 3 times ASHRAE to dilute it to get a quality air or a reasonable air. That's very expensive, requires additional equipment, and doesn't really give you a great product. Medium pressure UV is all we had for a while, and is helpful, very helpful. However, it's not the silver bullet. Trichloramine vapor is a problem. It's insoluble in water, which means once it's out, it's not going back in. It's highly volatile. The more activity in the pool, the more chloramines you get. It's very dense, so it sits on top of the water. And where do we swim? It's an extreme irritant and corrosive material. It'll do bad things to you and I and make you uncomfortable, as well as possible health effects down the line. And it will damage your building and structures prematurely, costing you dollars you don't need to spend. It'll beat up your retained earnings tremendously, and you'll have unanticipated costs of operation. A new way to deal with trichloramines. Don't fight it. Figure out what the chloramine does and use it to your advantage. Basically, what we're looking at here is a source capture option. We don't want to mix it in water because it's insoluble. Existing primary as a vapor in an active pool, it doesn't mix readily in air, so it's heavy, so it stays down. It tends to stratify, and we want to collect it at the water level, and without it, you have a chloramine bubble. And if they put the return on the HVAC up high, the whole building would have to be filled with the chloramine before it ever gets into the return in the recirculating system. All right, we're showing the old way here, and this is how most of them work. High return, high supply, builds a bubble on top of the water, and literally that bubble, the NCl3 vapor, would have to rise all the way to the return to even move it. And if you notice at the top, that little red arrow, the typical exhaust rate is 10 to 20% of the circulation rate. However, when it does that, 80 to 90% of the air goes right back into the facility. So we're returning contaminated air in the facility. Now, they would typically create a negative pressure in there, which means we'll exhaust 10 and 20%. We will bring in 8 to 18, so we remain slightly negative and keep the fumes out of the rest of your building. Now, this is a source capture exhaust operating system. This was shown in our 2011 presentation, at which time we had 3 facilities with it. Today we have 300. We've had more than 5 million people enjoy a source capture system, and it is truly something to experience. And if you notice in here, the return is high, but the air is sort of clear down there, and we're literally using the velocity across the pool and the power of the HVAC to move the bad air across the pool, pick it up down low, and exhaust it independently. Therefore, we'll have a fresh air loop with your air handling, supply and return, and a dedicated exhaust keeping it out of the pool. All right, source capture exhaust strategies for chloramine removal. Do's and don'ts. Don't mix the vapors in the fresh air loop. Okay, in other words, we want to get it out before it rises and is spread through the whole facility. Do not recirculate the vapor because we don't want to put it back in. Do capture it where it grows and it's basically coming out of the water, and we're the fuel. Do capture it as it forms. The key to a successful pool is to remove the chloramines as fast as they're produced. That is pretty possible with a source capture system. However, in the conventional system that recirculates it, when the dilution rate is exceeded by the production rate of chloramines, conditions deteriorate. That's why first day you can swim pretty good, second day is worse, third day, and then finals, you've got some, in some cases, some pretty horrendous air quality. And you do want to exhaust it outside independently. Source capture and exhaust strategies for the trichloramines. Okay, these are just some of the design considerations that the HVAC designer will use. You want a gentle flow across the room. Reason being, if the flow is too high, the evaporation will increase tremendously and you'll get cold. The source capture is designed to work with your system, so the energy of circulating 20,000 with an exhaust of 5,000 is used to sweep the air across the water and take it out in your source capture plenum. Source capture exhaust plenum should be as close to the water surface as possible. You can put it in your gutters, you could put it in your deck drain, which is a little farther back, or you could put it in a wall-mounted plenum, which is simply a draw plenum to get the chloramines out. The closer to the source, the more concentrated the removal the removal air is. When you do this, it keeps them out of the fresh air loop, which greatly improves the conditions. Source capture exhaust can take all or a portion of the ASHRAE required exhaust. In most cases, we can stay at the ASHRAE minimum. In some cases where there are high production, such as hot, active pools, the exhaust rate may be raised by the mechanical engineer. In this case, you may be able to reduce the air handler size, which is dollars, which means you have a upfront cost saving, and then you're also have the ability to reduce the energy in the room. Too much energy mixes it, and the mechanical designer will determine the flow rates. Advantages: chlorine bubble never forms. System removes the TCA vapor, which is a name for NaCl3, which are your chloramines, at the water line. The vapor is exhausted as part of all of the code requirement. It's reduced in the recirculating. You won't get all of it, but you'll greatly reduce it. The air handling costs are reduced because solution by dilution volumes are not required. And just a little aside for you, one additional 1,000 CFM of outside air provided in Charlotte is worth $5,000. 1,000 CFM of outside air per year requires 3 additional tons of dehumidification compression. This represents real dollars. Will also reduce corrosion, extend the life of your building, and it greatly improves the health impact on your swimmers, coaches, staff, spectators, giving them a great experience they expect and deserve. How do we test them? There's a VOC meters that are used by several of the HVAC folks, and it parallels the load in the pool because people create VOCs. It also parallels the air quality and the folks in the pool, and it's very similar to the rise and fall of chloramines. So that is a marker that can be used. Hire an engineer to do a time-based collection of chloramines. This is sort of expensive, but it'll tell you. There is a device that we've had some mixed results with, NEMO trichloramine meter. And this is used by Mr. Blatchley and his group in their studies, and he's had good success. All right, source capture, applications. As I spoke earlier, you could put it in the gutter, bottom left. You could put it at the building perimeter on your right, either at wall mount, plenum. It can be manufactured or it could be stick build. And then you've got it in your deck, which could serve as an exhaust plenum as well as a deck drain, which is not even seen. So it's pretty effective way to do it. All right, now I'm going to touch a few facilities that have had this. Jenks, Oklahoma. This pool was the second pool that ever received source capture. And it's a beautiful 50-meter, back sand filtration, bulkheads, and it's an event venue. On the right-hand side of the picture, they've probably got 1,000 spectators. The results from the source capture system were swimmers enjoyed the quality, comfortable air with no respiratory issues. The reason it came in that job, it literally was added to the job, why it was under construction, because the swim coach wanted to take care of his kids. I'll let you folks read this when you get a chance, but basically, John Turner had a couple swimmers that he coached to the junior national levels that could never finish out workouts because of breathing problems. Both athletes are now training full-time workouts at an entire level of intensity. So you're able to breathe better, you feel better, and you recover without respiratory distress. So the source capture is the way to go to enhance your air quality. This is the Westside Aquatic Center, which was really the start of source capture. This was in Greenville, South Carolina. They had a 50-meter and an indoor pool, and the pool basically was condemned because of structural damage from the chloramines. And in this particular facility, it probably has the best air in South Carolina. And the YMCA, our first one we put in was at a YMCA in Rock Hill, and the director moved to Greenville and brought that technology with him. This is a little description of the pool. They've got a 50 by 25 and they got a 25-yard teaching pool to boot. They replaced the facility in 17 years. So in reality, that 50-year building lasted 17, which cost them retained earnings of $175,000 per year. Pretty painful. The results, new state-of-the-art facility with fresh air, and the patrons, owners are very pleased with the results. And we've actually tested the chloramines, which are at 0.08 milligrams per meter cubed. All right, this is based on the World Aquatic, or the World Health Association's acceptable levels, which are 0.3 to 0.5 milligrams per meter cubed. So you can see the chloramines are very low in this facility. And in reality, they're imperceptible at 0.2 milligrams per meter cubed. So we have great air in this facility, probably the best in South Carolina. This is MERV's letter of review. Basically, they're swimming 600 swimmers with 3,000 spectators, 400 people warming up. When they first jump in, it shows up. Within 2 minutes, it disappears and never returns. This was something I never before witnessed in his 20 years of being in the aquatics. So again, great facility. This one is a special pool here. This is Queen's University, Charlotte. They designed this pool with the intent of source capture in mind, with a great HVAC system. And as you can see, it's a beautiful pool. This particular pool, if you see the banners on the wall, those are all NCAA Division II championships. They've had them 6 years in a row, men's and women's, once they put their source capture system to work. The results, collegiate athletes can enjoy great indoor air quality in the natatorium. They have no issues. Coach Jeff Dugdale literally can't go to a facility that's got high chloramines or he'll lose his voice. Everybody's talking, swimming, and feeling good, and they're doing a great job with their program. If you look at the credentials of the Queens group, 6 men's and women's championships. Coach Dugdale was the Jim Flowers USA Swimming Coach of the Year, 7 times CSCAA Coach of the Year, and he was on the U.S. national team as a coach. They run an unbelievable program. Now, last and least, all right, how's it go? Last and most important, young children exposed to chloramines in their developmental stage is a little bit scary. Extensive exposure to it can cause issues. There's lots of studies out there. So where should we really protect those little ones? Swim or Safe Splash Swim Labs in Fort Mill incorporated a source capture system in their facility, and they have no chlorine smell in the pool and the lobby. The teachers love it, the kids love it, and it is a great way to start them. So they have a positive experience when they learn to swim, not a negative. They basically put a dehumidification unit in there with source capture, no disinfectant byproducts in the fresh air loop, and they're doing very well. Leila O'Brien, the owner, went the second step further, incorporated a needlepoint bipolar ionization in the air system to enhance the air quality. And that is a device that aggregates particulate. It inhibits and reduces microbial growth in your HVAC system, extending the life. And it creates an environment of neutralizing pathogens in the air. Just a little bit from Layla. Safe Splash. As a mother of 2 daughters, we took swimming lessons when we were growing up. I experienced many facilities there, quality that was not a priority. Okay, I'm gonna go down to the bottom of it. When new families join Safe Splash, they usually were surprised at the low chlorine smell. And if they've been in previous facilities, the difference is even more shocking. The strong chlorine smell in most indoor facilities is caused by chloramine gases, which are not healthy to breathe over extended period of times. Our school, with the paddock evacuators, consistently removing these chloramines and providing us a premium air quality. All right, I'm pretty much done with my part of it. And what I wanted to do is let you know why I'm doing this presentation for the World Aquatic Health Conference and PHTA. And I want to thank you guys for caring and investing your time exploring the possibilities of enjoying and providing great indoor air experience. Great indoor air experiences are possible when new technologies and designs are utilized and best operating practices implemented by the facility operators. A lot of times we have the equipment, but understand if they're not run properly, they won't work well. Our goal is to deliver the pristine environment our patrons, staff, spectators deserve and expect. Hire an experienced design team and operating team to develop a defined air and water strategy for your new or existing pool. You may find this information helpful on your aquatics journey. If you have any more questions, you can reach out to us. With your help, we can establish a new standard of care, fresh air. Thank you, Don Baker. Some additional resources which recap and give you more detailed information on the information discussed above were sent initially to you by the PHTA to review prior to this demonstration. Suggested water and air quality recipe for success. This is a holistic approach, meaning everything is considered to help you be successful and create the environment you need. In addition, on a design side, there's some suggestions on addressing indoor air quality issues in natatoriums. This is an overview of the applications that we've seen from the 70s, 80s to where we are today. And this will give you some guidelines to be able to deal and speak with your designer and your team intelligently. And last of all, I would like to thank PHTA once again for allowing us to participate in this great cause. And I hope you find this helpful. Have a wonderful conference.